So today we will be solving lead code question 145, and that is binary tree post order traversal. And this will not be just a single question, because today we will be discussing about all the three traversals that we have been studying in order: left, root, right; pre-order, root, left and right; post order, left, right and root. We will be seeing a very simple pattern that we will be following to do a traversal of all these in a recursive fashion. So let's go on. First and foremost, I would like to tell that we need to return a vector. So we need to create a empty vector for us to return the vector. Okay. So vector of int resultant. So far so good, no problem. Just call the solver function and pass in the root and pass in the resultant vector, and then just return the resultant as it is specified in the question. In this question, what we want to do is the post order traversal. So let us see the generalized way. First we will be doing the post order, and then I will be generalizing this for in order and pre order. Okay, so let us go on. This will be a void solver function that will be getting our tree node star root and a vector of int ampersand resultant, and that goes. Whenever you see a null node, you may please return now. Just hear me out when I say these three lines. Okay, just be careful. What is post order? Left, right and root. Whenever there is a variable, whenever there is a time for a variable, please do recursively call, and whenever there is a surety of a root, please do insert. Whenever there is a variable to call, please do recursively call. Whenever there is a surety of root, please do append it into the array, cout or whatever you want. Okay, what I said, I'll just be writing it. Left is a variable, left is just a variable. Okay, in a recursive call, left being a variable, so I will be calling solver. Okay, root left res. Right is a variable in post order, left, root, right. So solver root right res. Then comes root. Root is a distinct, so it is not a variable. Okay, root is a root. Okay, so whenever we are at a node, that is a root node. Whenever we are at a node, is considerably that that is considerably the root node of that node, or that is a root node, whatever we consider it. But whenever we are at a node, we consider it as a root node. So if that is a root node, what you may do, you may please do res dot push back root value, and that is it. Left, root, right, and that is it. That is the answer. If I just return it, if I just run it, you may see that things are accepted. It will be submitted. And that is submitted. But the major thing that I am here to discuss is the leftovers, pre-order and post-order. What things might change in pre-order and post-order? In pre-order and in order we have left, root and right. So in to make this post-order in order, what it is said, left, root and right. We will just be placing our root here. That becomes an in order traversal. If I just run it, it will not be accepted because this is an in order traversal. Okay, you may see one. What is in order? Left, root and right. So left first, as it is not having any left value, so 1. Then it went to 2. 2, do you have any left? Yes. 3. So at first 3 and then 2. Root left and right, leftmost and then right. Root leftmost and then right. In order done. For empty, that would not be anything, and for 1, that would be the same thing. But yeah, we are doing an in order traversal. You may confirm it from any source you want. This is an in order traversal. For this output, this is an in order traversal. And why we are getting wrong? Because we want an post order in this question, but we are doing an in order. Just to explain you guys what things are really we need to change for us to do an in order traversal. Now, what is left is a post order traversal. What post order says? Root left and right. So please do place this portion above all this, and yes, you get your pre-order traversal, root left and right, and that is it. If I just run it, you will be seeing that 1 2 3 root left and right. Root 1 left does not exist, right exist, inserted, 2 root, now this becomes my root, left exists, inserted, 3 right does not exist, return, and return, and that is it. We are good to go for these two. That will be again the same case, 1 empty and a single node, and that is it. That was the simplest approach in a recursive fashion for in order, pre-order and post order. I think that is it. That was the logic behind how we are changing the pushback statement. Whenever we want an in order, we will be placing the pushback between the left and right. Whenever we want a pre-order, we will be placing the pushback at the top of left and right. Whenever we want a post order, we will place the pushback at the bottom of left and right. Okay, after left, right, and then pushback in a post order. Sorry. So that is it for the video. I hope you enjoyed it, and I hope that was an insightful video. If you like the video, please do comment down your thoughts in the comment section, and we'll be meeting in the next video. Till then, bye and take care and keep coding.
Hold me close till I get up.